Welcome. My name is Trisha Morris, and I would like to welcome you to my channel, Mathematics Simplex, where you will be able to view videos you might find difficult in your class. Please don't forget to subscribe to my channel, and also don't forget to like my video. Today I'll be talking about set theory. And the first thing that I'm going to discuss, what do we mean by sets? Now, a set is a collection of items, but today I'll be talking about a collection of numbers. There are different types of numbers, and the numbers are called real number systems. Now, real number systems are any number that you can think about that exists. Now, the first number that I will talk about is natural numbers. Natural numbers are like counting numbers where we start from 1. So you have 1, 2, 3, 4, 5, and it continues. The next number we have is a whole number where whole number starts from 0. So you have 0, 1, 2, 3, and it continues. Have integers, where integers consist of negative and positive numbers. The integers consist of negative and positive numbers. So we have -3, -2, -1, 0, 1, 2, 3, and it continues. So if you realize it continues on the negative side and the positive side. Now you should realize that integers consist of the whole numbers and natural numbers. We have rational numbers represented by Q, where rational numbers are numbers that can be expressed as a fraction. And fractions means that we can have a numerator and a denominator. And having that, when you think about a fraction, we think about 3/4. We also think about a half. But what about the ones that are not that obvious? For example, 0.3. That's a fraction, which is 3/10. Or we can think about the number -2. -2 is the same thing as -2/1, or +3, still a fraction because it's 3/1. Once I'm able to see a numerator and a denominator, so it means 0 can be considered to be rational because 0 over any number is a fraction. Finally, we have irrational numbers, and irrational numbers are numbers that cannot be expressed as a fraction. So, cannot be expressed as a fraction, we have the square root of 2, square root of 3, these are considered to be surds. We have pi, the symbol, along with e, which has repetition of numbers that has no pattern. We can just write a number 0.3152778, and it continues, and this is considered to be irrational. Now we could represent this real number, because all of these numbers is a part of the real number system, and we could represent it on a diagram. So I have my diagram, and the first one we'll have is the natural numbers. After natural numbers, we have whole numbers. After whole numbers, we have integers. I'm going to put the Z with a cross so that you know that that's a Z. And the next one, we have rational numbers. And outside the set, we have irrational numbers. So for the real number system R, if you look at this, irrational numbers is never within the set where we have these subsets. So rational numbers consist of integers, whole numbers, and natural numbers, while integers consist of whole numbers and natural numbers, and whole numbers consist of natural numbers. I'm going to look at set builder and interval notation. Now, just to talk a little bit about set builder notation, this is just a symbol, another way that we can represent a set of numbers. So we have x is such that x is an element of the real number system where x is would have greater than or equal to, so a symbol will fall within this region, which you'll see later on. Now, so for set interval notation, we have the brackets where this means open and the square brackets means closed. And open means we're not using the end value, while the square bracket means we are actually using the end values. So now I'll be doing an activity. Suppose we have a being -3 and 5. If I need to have this as set builder notation, I'll have x is such that x is an element of the real number. So x is greater than or equal to -3, but less than 5. Now, if you look at this, it's telling me it's between -3 and 5. Once you have this square bracket, then on this side for -3, I'm going to have equal to. Because we have a curved bracket, meaning we're not using the 5, then we're not going to have any equal to here. Now, if I'm going to represent this on a number line, I will have the numbers -3 and 5. And if you look at this, I have -3 in the exact position that it will fall and 5 in the next position. And if you want to have a 0 marker to show the difference where it's negative and the positive side, that is okay. Now at -3, because we're using it and we're having equal to here, and also at the square bracket tells us we're using it, I will expect to have a shaded dot above the -3. While here, so at -3, I'm expecting to see a shaded circle, while at 5, it will be open. So I will be having an open circle with no shade within and connecting this, and this represents A. Now, suppose we have B to be -3 and 16. Again, we're going to have x is greater than -3 but less than 16. So it's always going to be x is such that x is an element of a real number, and then the brackets, we re-represent it in terms of inequality, where we have x is greater than the -3, but less than 16. So the bracket is just saying the numbers lie between -3 and 16. Now, to represent this on the number line, we're going to have -3, then I'll have my 16, and again, the position is very important. We cannot have 16 over the negative side. Now, if you look at the inequality, both of them are open. So since both are open, that means I'll have my open circle without any shade within, and connect the dots. Above -3, it's open because we don't have any equal to inequality. And it's the same thing with the curve bracket. Same thing for 16, it is not open, meaning no equal to, no square bracket, so it's open above 60. And this represents B. So say, for example, we have A to be -5 and positive infinity. Because -5 has a curved bracket, I'll have it being open here, and it's going towards positive infinity, so I'm continuing. So I'll have an open circle here, then I'm continuing towards infinity on the positive side. Once I have this, if you look at it, infinity is not a number. So when I'm going to write this inequality, I'll have the number x, but this arrowhead, I'll be removing it just as how it is and put it on the right-hand side of x. So I'll have greater than, and then you put the number, which is -5. So say, for example, we have A to be -infinity to 3. First, I'm going to represent this on a number line. So we have the number 3, and we're using negative infinity. Now, 3 at 3, it's closed. I'll have a shaded circle above 3. We're moving towards negative infinity, so I'll be moving towards the negative side. And if you look at what I have, x, we're going to take the arrowhead, and again, we're going to put it on the right-hand side of x. So now we're seeing x is less than, but because of this square bracket, it's going to be less than or equal to 3. So the set builder here is saying x is such that x is an element, a real number, where x is lesser than or equal to 3. We have two sets, A being -3 and 5, and B -1 and 12, and make note of the brackets that we have. Remember, if you have a curved bracket, it means open, while if I have a square bracket, it means closed. Open means we are not using the end value, while closed means we are using this end value. So let me draw my number line. So we have -3 and the number 5. We have -1 and the number 12. Now this is just an estimation, it's not accurate. At -3 for A, it's open. At 5, it's closed. And here we have A. Looking at A union B, A and B covers the number line. Where do we start and where do we stop? So at -3, if you realize we start at -3 for A and we stop at 12 for B. So it means A union B, I'll have -3 and 12. Now at -3, we have it being open, so I'll have a curved bracket. And at 12, it will also be a curved bracket because it's also open. So this will be our interval notation. Now, if I want my set builder, we'll have x is such that x is an element of the real number system. And because we have two numbers, we're not going to have x is greater than and less than. Now, because of these curved brackets, I will not have any equal to here. So I'll have x is greater than -3, but lesser than 12. Now, suppose that we have A union B complement. Now, A union B complement means that we're finding the values outside of this set, -3 and 12. So I'm going to draw this on a number line where I have -3 and 12, and it's open at -3, open at 12, and this represents A union B. But the question that I have here is A union B complement. Now, complement is outside the set. So we're looking for all the elements that are outside the set. Now, since -3 is not being used by this red set, it means it's outside the set. So I'm going to have it being closed at -3, and I continue towards negative infinity. Same thing at 12, open. So it means it is not within this red set, so it must be outside the set. So I'm going to have it being closed outside the set and it going towards positive infinity. So the complement means everything outside. So it means if I'm going to represent this as an interval, I will have open at negative infinity, but at -3, I will have closed because of the shaded region. Union 12, but at 12, it will also be closed, and we're going towards infinity, the positive infinity, and it will be open. I want to go ahead and represent this in the set builder. Then remember, when we have negative infinity, we look at the arrowhead. So it means I'll have x, take off the arrowhead, just as how it is. So it'll be less than -3, but because at -3 we have a square bracket, it's going to be x is lesser than or equal to -3. Or for my second bracket, again, we look at the arrowhead that we have here. So I'll have x greater than sign symbol. So we remove it, put it right on the right hand side of x. And then I will have the number 12. Now, because at 12 we have a square bracket, then I'll have to have an equal to here. And this is my set builder, where x is such that x is an element, a real number, where x is lesser than or equal to -3, or x is greater than or equal to 12. Suppose we want A intersect B. Now, A intersect B is where we have an overlap. So the overlap area is between -1 and 5. Now at -1, both A and B are using it, shaded, solid line. So it means that I can have a square bracket. The same goes for 5. Now, suppose we had an open symbol here. So if this was open, then it means I'll have an open symbol here for the interval, which will be the curved bracket. Now, representing A intersect B as the set builder, then I'll have X is such that X is an elementary real number. So that X is, now remember, we always have this inequality, but now we have a square bracket, so I'll have to go ahead and put equal to, then I have -1 and 5. We can also have A intersect B complement, and A intersect B complement is we are talking about outside of A intersect B. So again, I have my number line, and I'm going to have -1 and 5. Now at -1 and 5, we are using the end values. So I'm going to have the shaded region, and we connect. So this represents A intersect B. However, I'm asking for the complement. So if I need the complement, complement means everything outside the set. So if I'm going to talk about everything outside the set, then it means that if I look at -1, it is being used by the intersection. So it cannot be outside the set, so I'll have open to represent it's not outside. And then we cover all the area outside the set. The same goes for 5. At 5, if you realize, we have this number being used by the set. So I'm going to have an open circle here, and we're going towards positive infinity. So it means that my interval is going to be -infinity, -1. Because of this open circle, I am going to have a curved bracket, and we're going towards -infinity. So I'm going to also have a curved bracket. Remember, infinity is not a number, so we can never have a square bracket here. Union, then we have 5, positive infinity. At 5, we have it being open. So again, we have open, and then infinity can never be closed, so I have an open circle. Now, if I want to represent this as a set builder notation, then what I will write for this side, remember we look at the arrowhead that we have here. So it's going to be X, and we take the arrowhead just as it is, attach it on the right hand side. So X is less than -1, or the next side, take the arrowhead. So we're going to have X is greater than 5. Just remember, we have strictly less than and strictly greater than, because -1, it's open. Now, say we have A to be -3 and 4, and infinity. Now, if we want to go ahead and represent this on a number line, it's a good idea to represent it on a number line so you have a better idea of what is happening. So looking at this, we have the numbers -3, 4, 0, and since I already have positive infinity, I'll just include negative infinity. So for A, we have negative 3 being open and 4 being open. So this is A. For B, I have it being open at 0, and it's always going to be going towards positive infinity. That's always open. So this is B. It's A minus B. Now, A minus B means A only. Now, for A only means only the elements of A. So we know it's going to be negative 3 and 0 because that's the region where we're not seeing any overlap. Only thing we have to look at is a bracket. Now at negative 3, it automatically is not using it, so I know it's going to be open. Now at 0, because it is open at 0 for B, then it means we can have it being closed for A only. A only means elements in A alone. If you look at 0, if this was closed, that means both A and B are using it. If A and B are using it, we cannot have a square bracket here. But since in this case, B is not using it, it is okay for me to have it being squared. So in other words, for A only, because this is open, we're going to have this being closed. So if this was closed, then we'll have the 0 being open. If we're going to represent this as a set builder, we'll have X is such that X is an element of the real number where X is greater than negative 3 and lesser than or equal to 0. Now, if I ask for A minus B complement, let's look at this one. Again, you can draw a number line where we have A minus B. Now, A minus B is negative 3 and 0. Negative 3 you will have open, and 0 you'll have closed. So this is A minus B. Now I want the complement of this. So if I'm looking for the complement of this, the complement take into consideration everything that is outside the set, this red set. So since it is closed at this end, it means outside the set, it is going to be open and it goes towards positive infinity. So in other words, 0 is within the red set, so it cannot be in the blue set. Looking on the next side, negative 3 is not within the red set, so it means it is outside the set and it goes towards negative infinity. So it means that A minus B complement, if I'm going to represent it as an interval, I'll have negative infinity and negative 3. But because we know negative infinity can never have a square bracket, we're going to have a curved bracket here. While at negative 3, we're going to have the blue shaded. So therefore, it's going to be a square bracket. The next interval, we have 0 and infinity. So it means at 0, I'm going to have an open bracket. And at infinity, we're also going to have an open bracket. Now, I'm not going to do the set builder. You can do that on your own. What I like to look at is A union B. So A union B, where do we start? We start at negative 3, and where do we stop? we're not stopping, we're going towards positive infinity. So it goes towards infinity. So we open at -3 and open at infinity. So the question I have, and before I even ask the question, if I'm going to do the set builder, then it'll be x is such that if we have the set builder, we'll have x is such that x is an element of real number where x, now since we have -3 to positive infinity, it will be greater than -3. So once you have curved brackets, it's going to be strictly greater than, and because we want greater numbers, that's why we're using a greater than sign. So my last question for this activity is A union B complement. So let us represent A union B on the number line. You have -3 and infinity. This is what we have for A union B. So if you look at this, we're using all of the positive side. So it means what we have left is a negative side. Now remember, complement is the opposite. So if this is open, then it means this should be closed. And we're going towards a negative infinity side. So it means as an interval, this is minus infinity, and this is -3, but if we close that -3 and open at negative infinity. So if we're going to represent this, we will have x is less than or equal to -3. So the set builder for A union B complement is x is such that x is an element of real number where x is lesser than or equal to -3. Thank you so much for listening. Please subscribe to my channel and I hope you enjoyed my video.